Fundamental forces of nature. Encompassed in the laws of motion, there are both centripetal and centrifugal forces at play, with varying motion vectors or potential motion vectors in varying directions. There are also similarities of centripetal and centrifugal forces found in nature to the ones in planetary bodies like gravity, the inward force, encompassing all of matter, and the cosmological constant, the outward force, holding the planets in orbit, making sure that we do not crash into the sun. These adjectives are different names to express similar concepts. Another name for the outward force, possibly a more recognizable term than the cosmological constant, with the use and assumption that galaxies are moving away exponentially. It was named after Edwin Hubble the Hubble constant, and is an outward force, including the acceleration of the universe at its endpoints. The Hubble constant and the cosmological constant are observations of the pushing force of the galaxy. These forces could be derivatives of the same force. Either force's magnitude is not completely detectable in the universe and is hard to identify because of its integration with gravity. If you break down the forces in incremental parts, even on the vibrational level, there are some forces at work in emotional observation. One such example is turning a corner in a car. In that example, it is likely that you can feel both forces. The first force is the one you feel going inward when the car enters the turn, and the other is the opposite outward force that acts upon objects as you come out of the turn. In this example, when you turn with your car into the center of the turn, your center of gravity moves with you into the turn. There's a large pull due to motion that can be expressed with an inside vector facing the turn. After the turn is complete, when the car switches direction and comes out of the turn, the centripetal force that was there going into the turn now switches to a centrifugal force, pulling your center of gravity outward, completing the turn. Therefore, if you take the same situation and apply it to a continuum, then there is a point in which the centripetal and centrifugal forces are at equilibrium. If you apply the same concept to the cosmos, then an Einsteinian Hubble equilibrium exists, demonstrated by numerous planetary bodies, stars in the solar system, and our own escape velocity equilibrium. In our pursuits to identify a force to explain planetary bodies, we can revert to our Einsteinian selves and regard the cosmological constant a great pillar of understanding in our universe. It is the demonstrative force underpinning the understanding of galaxies moving away if they are moving away in parts of the universe. It is also strictly a repulsive force, which Newton's third law has difficulty offering a conceptual opposite reaction that the cosmological constant offers. Ironically, Einstein stated the cosmological constant was his biggest blunder. Like the term spacetime, cosmic gravity, denoted by the nomenclature lambda g, is a perfect mixture of the two forces, explaining the reasoning why our planets do not crash into the sun. They simply are in a state of equilibrium, spinning in infinity, even though the sun's gravity is 700 times more massive than all the planets, according to how the universe works. It is still a mystery of which force better describes the aggregate force of motion and gravity. Newton's theory offers an easier unification point of the fundamental forces, with both repulsive and attractive aspects incorporated into one force called gravity. Einstein and Hubble's constant is descriptively a more attractive philosophy, creating a name for repulsion and possibly someday a constant, explaining deep space findings that are not related to redshift. The concept of Newton's third law, an equal and opposite reaction, is in regards to planetary bodies having an opposite reaction to matter, which lends itself to the fact that it's impossible that the gravity is a solely attractive force operating in the solar system. If that were true, the sun's gravitational pull would make the Earth and all 8 planets and eventually numerous stars crash into it. There must be an intrusive outward force in the universe of some capacity. The ideals of cosmic gravity and the spinning bodies lend themselves to bodies at rest as well as in inertial frames of reference in the equilibrium with each other. The force of gravity and cosmological constant have a cosmic relationship to behave in unity with each other and ergo facilitate a push and pull vector quantity. Above in figure 1 is a picture of a hydrogen atom in perpetual equilibrium. Both the pushing and pulling force are acting on it. You can see its outer shell, which is in equilibrium with its nucleus. Very much a pushing of vibrational bodies to the exterior of the atom. It is most likely could not expand any larger given the amount of the combination of the lambda g force. You can plainly see the nucleus with the center of mass pushing and pulling the matter. This observation is seen in areas of atomic structures as well as the majority of galaxies, encompassing this mostly static universe. These sequential vibrations make up the core of the energy in the nucleus and bind the strong nuclear force in an atom with gluons holding it together. According to commonly held strong nuclear force proponents, also in figure 1, the potential motion inward and outward that you can see could also be described as centrifugal centripetal parity in course and trajectory. Even the immense energy that pushes the electron circle inward and outward, there is proof of an amazing dynamic of nature. Symmetry, preserving a perfect circular shape of mass and energy. It seems like the outer shell of figure 1 was affected by the concept akin to dark energy pulling the outer shell outwards until it was in equilibrium to gravity, which causes the atom to come to rest in the state that we see above. In the above pictures, which represent possible forms of matter lying in different physical states under a microscope, it is a challenge for individuals to describe all of matter and life in the universe with just one theory. As you can see, the idea of a strong nuclear force holding the nucleus together is palatable in the above figure of the atom. It is displaying the traditional atomic structure that is often taught in elementary school and beyond. If you use your imagination, the figure could be a snapshot of a solar system and a direct link to unified quantum mechanics to classical mechanics that most cosmologists are searching for in one model. The figure above model is a particular favorite in those that diagnose the energy within as being a systematic interpretation of the strong energy force. Although the model does not encompass all shapes and energy densities found in nature, just central examples of matter that look as though they contain energy inside.